So, yesterday we have talked about the software requirements document. We have specified the users of a requirements document, the structure of a requirements document, and then we had concentrated on on the specification of requirements, where we have seen the different ways of writing a system requirements specification. Some example requirements for the insulin pump software system. We have seen also a structured specification of a requirement for the system. And at the end of the last class, we have seen the tabular specification, and we have also taken the example of an insulin pump to see the tabular specification of computation. Do you remember these points that we have mentioned in the last in class? That means yesterday. So I'll ask you a little question, a small question, as in the homework. Do you remember the users of a requirements document? Users of a requirements document. Any ideas? Yeah. Customers, managers, engineers. Yeah. And engineers is a big notion. Engineers may include many different people. Can you specify more about engineers, please? System engineers, tester, and system test engineers, maintenance as system maintenance engineers. Perfect. Thank you, Rory. Yeah. In the previous yesterday, we have talked about these possible readers or users of our requirements document. As we have so many different people, coming from different backgrounds, and we have specified the importance of natural language in the writing requirement specification, because we cannot guarantee all people can understand what our jargon or abbreviation mean. So it's better to use natural language and to describe the requirements as clearly as possible. And now we'll continue with the requirements engineering process. Here, we have a spiral view of the requirements engineering process like this. And in the second chapter, we have also talked about requirements engineering process. And we said that this, the requirements engineering processes include 4-level activities. Do you remember the 4 activities included in requirements engineering process? In the second chapter, we have talked about this thing. If you have, I think you have the slides, the PPTs, so perhaps you can find them easily. The 4 activities included in requirements engineering processes. Any propositions for those 4 activities? In chapter 2, we have talked about these 4 activities in requirements engineering process. At first, when we need, at first we need to assess if the system is useful or not to the business, and what we can call this activity. Kaya, thank you. Feasibility, the feasibility study. This is the first activity, and the others we discover the requirements. And requirements elimination. It's elicitation, I think. Yeah, requirements elicitation and analysis, requirements specification. Yeah. Here and requirements validation. Very good. Thank you very much, Kaya. Yeah, this one. It's not elimination. We don't eliminate it, but elicitation. Yeah. Thank you. Yeah. Exactly. Elicitation. These four activities: feasibility study, requirements elicitation and analysis, requirements specification, and the requirements validation. Yeah, very good. Thank you, Kaya. Yeah, I'll show you the slides we have. Yeah, here. It was in the second chapter. We have talked about the software specification. There we have talked about the requirements engineering process. In the first, it includes four activities. The first one is the feasibility study, where we ask the question if it is technically and financially feasible to build the system. This one is to see if the system is useful or not to the business. And the second activity is the requirements elicitation and analysis. We may ask the question, what do the system stakeholders require or expect from the system? Here we discover the requirements. And then we continue with the requirements specification to define the requirements in detail. That means we convert these discovered requirements into some standard form specification. And then we pass to the requirements validation to check the validity of the requirements. That means to check if the requirements actually define the system that the customer wants. Yeah, these are the four activities. And we had also our figure to show the relationship between these activities. We have seen that we can consider these activities as sequential processes, but it is among them we have also some interaction. That means the activities are also interleaved. It is a iterative process in which the activities are interleaved. Okay, this is a small review of what we have learned in the second chapter relating to our new knowledge. Here we'll continue in this chapter. In this class, we'll also talk about the requirements engineering process. What is shown here is the spiral view of the requirements engineering process, and we see that here the activities are also interleaved. You see in this figure the activities are organized. Here the activities are organized as a iterative process around a spiral, with the output being a system requirements document. And among these activities, the amount of time and effort devoted to each activity in each iteration depends on the stage of the overall process and the type of system being developed. We see early in the process, we start by here, and early in the process, most effort will be spent on understanding high-level business and the feasibility, some some non-functional requirements and the user requirements for the system. And later in the process, in the outer rings of the spiral, we see more effort will be devoted to eliciting and understanding the detailed system requirements. Yeah, this is the another view of this spiral model. As we have said before, the processes used for requirements engineering vary widely depending on the application domain, the people involved, and the organization developing the requirements. However, when we see the spiral view of the requirements engineering process, we see that there are a number of generic activities common to all processes. As we say, the requirements elicitation, analysis, validation, and management. In fact, when we develop a system, requirements engineering is an iterative activity in which these processes are interleaved. Now we'll see the first one, the requirements elicitation and analysis in detail. Yeah, as said by Kaya, for the requirements engineering process, the first stage is our initial feasibility. After that, we'll begin our next stage that means the requirements elicitation and analysis. Here, this stage, sometimes we call it requirements elicitation or requirements discovery. In this stage, normally software engineers work with customers and other system end users to find out about the application domain, the services that the system should provide, and the system's operational constraints. That means the required performance of the system, hardware constraints, etc. So we see that here in this stage, requirements, elicitation, and analysis may involve a variety of different kinds of people in an organization. We can have end users, managers, engineers involved in maintenance, domain experts, trade unions, etc. And these people, we can call them stakeholders. A system stakeholder is anyone who should have some direct or indirect influence on the system requirements. And stakeholders include end users who will interact with the system and anyone else in an organization who will be affected by the system. Here, this figure shows a process model of the elicitation and analysis process. Here we see that the process activities include four activities. The first one is the requirements discovery. Then we have the requirements classification and organization. Later, we have a requirements prioritization and negotiation. At last, we have the requirements specification. And pay attention. It is a cycle. That means we can turn back to requirements discovery. As we have said before, software engineers work with a range of stakeholders to find out about the application domain, the services that the system should provide, the required system performance, hardware constraints, and other systems, etc. And these four stages are included in the requirements elicitation and analysis process. And the discovery of requirements, classification and organization, prioritization and negotiation. And the last one is the specification of requirements. Now we'll see these four stages in detail. The first one is the requirements discovery. This process, we interact with the stakeholders to discover their requirements. Domain requirements are also discovered at this stage. Because domain requirements, it's only with stakeholders and documentations that we can discover during this activity. Yeah, later we will discuss some complementary techniques that can be useful for requirements discovery. And for the requirements classification and organization, this activity will take the unstructured collection of requirements, and then we group these related requirements and organize them into coherent clusters. And a common way to group requirements is to use a model of the system architecture to define subsystems and to associate requirements with each subsystem. The third activity is the prioritization and negotiation. Here, we prioritize requirements and resolve requirements conflicts. As we see, when we have multiple stakeholders, requirements may create some conflict. So in this activity, we need to prioritize the requirements and find ways or resolve requirements conflicts through negotiation. Usually stakeholders have to meet together to resolve differences and agree on compromise requirements. And the last activity is the requirements specification. In this activity, the requirements are documented and input into the next round of the spiral. And we may also, we see at the end of the spiral, we see requirements documents. And after this activity, we may also produce some formal or informal requirements documents. In the figure, we have seen that these requirements elicitation and analysis is an iterative process with continual feedback from each activity to other activity. Especially in this figure, we have it's clearly we see clearly that the process cycle starts with requirements discovery and ends with requirements specification. That means we will have probably have a requirements documentation, and normally the analysis understanding of the requirements improves with each round of the cycle. This cycle will end when the requirements document is complete. However, eliciting and understanding requirements from system stakeholders is a difficult process as we have different reasons. We'll see the reasons causing problems of requirements elicitation. The first reason is that stakeholders don't know what they really want. Usually, stakeholders don't know what they want from a computer system, except they know in the most general terms. And stakeholders may find it difficult to articulate what they want the system to do. They may also make unrealistic demands because they don't know what is or isn't feasible. That's a big difference between people working in different domains. The second reason is that stakeholders express requirements in their own terms. Stakeholders in a system naturally express requirements in their own terms and with implicit knowledge of their own work. For us, requirements engineers, we don't have experience in the customer's domain, and we may not understand these requirements they expressed in their own terms. The third reason is that different stakeholders may have conflicting requirements. Yeah, and we may have various stakeholders who have different requirements. Also, they may express these different requirements in different ways. So when we work as requirements engineers, we have to discover all potential sources of requirements and discover commonalities and conflict between these different requirements. The fourth reason is that organizational and political factors may influence the system requirements. Here, political factors may influence the requirements of a system, and managers may demand specific system requirements because these will allow them to increase their influence in the organization. A next reason for the difficult is that the requirements change during the analysis process. New stakeholders may emerge and the business environment change. Here, the economic and business environment in which the analysis takes place is dynamic. We may change during the analysis process, and the importance of particular requirements may change. New requirements may also emerge from new stakeholders who were not originally consulted. So this will, in this situation, we may also have some problems of requirements elicitation. Here we see that these reasons include different parts of the communication, the misunderstanding between stakeholders and developers or requirements engineers. That's why the communication is very important. And normally, as we have said before, different stakeholders have different views on the requirements, also on the importance and the priority of requirements. Yeah, when we have this kind of conflict between their views, normally we should organize regular stakeholder negotiations so that it will be much easier to reach compromises. Also, in practice, it is impossible to completely satisfy all stakeholders. But if some of them feel that their views have not been properly considered, then they may create some problems for the requirements engineering process. So it's better to have some, at least, mental preparation. Now we'll talk about some techniques in the requirements discovery. First, we'll see more in detail what's the requirements discovery. Here, in this process, we will gather information about the required and existing systems and distilling the user and system requirements from these the information we have gathered. Normally, we have different sources of information. We may have documentation, system stakeholders, and specification of similar systems. Yeah. When we want to get, it's important to get information from the system stakeholders. And when we interact with them, we may through different ways like interviews, observations, or scenarios, prototypes, etc. In this way, we can help stakeholders understand what the system will be like. Yeah, as we have said before, stakeholders range from end users of a system through managers to external stakeholders such as regulators who will certify the acceptability of the system. We need to interact with all these different stakeholders. And system stakeholders will provide different kinds of information. Oh yeah, systems normally have a range of stakeholders. Here we have an example of information provided by stakeholders for the mental health care patient information system. Yeah, we have some information like patients whose information is recorded in the system. Doctors, yeah, these are the stakeholders we may consult for the information. We can have the stakeholders like patients or doctors, as doctors are responsible for assessing and treating patients. Another stakeholder will be nurses. They coordinate the consultations with doctors and administer some treatments. Also, we will have medical receptionists as they manage patients' appointments. We can have IT staff who are responsible for installing and maintaining the system. We have also medical ethics manager. He will, these managers will ensure that the system meets current ethical guidelines for patient care. Another kind of stakeholder will be healthcare managers, as they obtain management information from the system. We have also medical records staff who are responsible to ensure that system information can be maintained and preserved, and that record keeping procedures have been properly implemented. As we have seen before, in addition to these system stakeholders, requirements may also come from the application domain and from other systems that interact with the system to be specified. All these different information should be considered during the requirements elicitation process. Now we are beginning to see different techniques of requirements discovery in detail. Yeah, the first one is the interviewer. Interviewer may include formal and informal interviews. Here, formal or informal interviews with system stakeholders are part of most requirements engineering processes. And in these interviews, the requirements engineering team will put some questions to stakeholders about the system that they currently use and the system to be developed. Then we will derive from the answers the requirements to from the answers to these questions about the requirements. Okay, perhaps it's better to have to give you some questions, else you don't. I cannot see any reaction. Can you? We have repeated several times the importance of communication between the communication with stakeholders. Can you explain the definition of a system stakeholder, please.
Laoshi, I think
Yeah.
system stakeholders are the people who are either going to be affected or are going to use the software. So those people are, in the example given before, the patients, the doctors, the nurses. Those are the
Yeah.
people who are going to use the software and be able to, use it. I think that's the definition for system stakeholders.
Yeah, perfect. Thank you very much, Kaya. And yeah, as you said, some end users, the end users, they are system stakeholders. We have also some other people like people who will like us. We are IT staff. We are responsible for the installation or maintenance of the system. We are also system stakeholders. Yeah, and Kaya, you are perfect. You are yeah, totally right. The end users like patients, nurses, the doctors, or reception needs. These different people who will use the system, they are also system stakeholders. Thank you very much, Kaya. And now perhaps it's better to have 10 minutes of break. Viewer, we have said that formal or informal interviews with stakeholders are part of most requirements engineering processes. And usually we may have two types of interviews. One is the closed interviews, where the stakeholders answers a predefined or predetermined list of questions. And the second type of interview is the open interviews, in which there is no predefined agenda. So here we may have a range of issues or various issues are explored with stakeholders. That means when we choose this type of interview, for us, the requirements engineering team, we should explore a range of issues with system stakeholders, and then we'll develop a better understanding of their needs. That means the needs of the stakeholders. Usually, effective interviews have several characteristics. Being an effective interviewers, we should be open-minded. We should avoid preconceived ideas about the requirements, and we should be willing to listen to stakeholders. If the stakeholder comes up with surprising requirements, then that means they are really willing to change their mind about the system. Also, as an effective interviewer, we should prompt the interviewee to get discussion going using a springboard question, a requirements proposal, or by working together on a prototype team. Yeah, when we do some interviews, if we say to people, tell me what you want, yeah, in the most of time, we are unlikely to result in useful information. Normally, it's much easier to talk in a defined context rather than in general terms. So normally, we need to have a requirements proposal. In practice, interviews with stakeholders are normally a mixture of both kinds of the interview, like closed interviews and open interviews. We may have to obtain the answer to certain questions, but these answers usually lead to other issues that are discussed in a less structured way. So completely open-ended discussions rarely work well, and we usually have to ask some questions to get started, and then we need to keep the interview focused on the system to be developed. Interviews are good for getting an overall understanding of what stakeholders do and how they might interact with the system. That means people like talking about their work, so they are usually happy to get involved in interviews. Therefore, normally interviews will be efficient. However, interviews are not so helpful in understanding the requirements from the application domain, and it can be difficult to elicit domain knowledge through interviews, as there are at least two general reasons. The first one is that requirements engineers cannot understand specific domain terminology. I think it is a general problem that application specialists, they often use terminology and jargon that are specific to their domains. It is quite impossible for these specialists to discuss domain requirements without using the terminology. And they normally use terminology in a precise and subtle way that is easy for requirements engineers to misunderstand. So it is difficult for us to get useful information with these domain terminology. And the second reason is that some domain knowledge is so familiar that people find it hard to articulate or think that it isn't worth articulating. Some domain knowledge is very familiar to stakeholders that either they find it difficult to explain or they will think it is so fundamental that it isn't worth mentioning. Take an example of in a library. A librarian, perhaps he will think normally classification is very general and very common. For them, their habitude is to categorize the books when they have before putting them on the shelves. So for them, they may it goes without saying that all acquisitions are cataloged before they are added to the library. However, for us, this may not be obvious to us interviewer, and then perhaps we will not take this thing into account in the requirements, and in this way we will create some problems. This part is for the interviewing. We have said that we have two types of interviews: closed interviews, open interviews. To be effective, we need to be open-minded. We should also prepare some springboard questions or requirements proposals. However, it can be difficult to elicit domain knowledge through interviews, as we have several reasons. Okay, now we'll see another technique to discover requirements, which is the scenario. People usually find it easier to relate to real life examples rather than abstract descriptions. And scenarios are real-life examples of how a system can be used. A scenario starts with an outline of the interaction, and during the elicitation process, details are added to the outline of the interaction and recreate a complete description of that interaction. Here, in general, a scenario may include these information, like a description of the starting situation, the normal flow of events, a description of what we can go wrong, and also how the problem is handled. We need to include information about other concurrent activities that might be going on at the same time. A description of the state, as in the system state, when the scenario finishes. Here, we have an example of scenario for collecting medical history in the system we have seen before. The use case, we have taken it for many times as an example. Usually a scenario like this, it means we need to work with stakeholders to identify scenarios and to capture details to be included in these scenarios. Normally scenarios may be written as text as this one, supplemented by diagrams, screenshots, or alternatively a more structured approach such as event, scenarios, or use cases may also be used. We may have occasion to talk about some other diagrams later. Here, we will look at this scenario in detail. As we have said, we include the initial assumption, the normal case, the normal situation. We see here the initial assumption is the patient has seen a medical receptionist who has created a record in the system and collected the patient's personal information. A nurse is logged onto the system and is collecting medical history. Here, normally, the nurse searches for the patient by family name. If there is more than one patient with the same surname, the given name and date of birth are used to identify the patient. Then and the nurse chooses the menu option to add medical history. Later, we need to follow a series of prompts from the system to enter information about consultations elsewhere on mental health problems, etc. And as we have seen before, we need to include also a description of what can go wrong and how the problem is handled. Here, in this scenario, we say that the patient's record does not exist or cannot be found. The nurse should create a new record and record personal information. You see here is what can go wrong in this situation and how we handle the problem. The second situation is also in this principle. Patient conditions or medication are not entered in the menu, so the nurse should choose the other option and enter free text describing the condition or medication. We should also include information about other activities that might be going on at the same time. What will be the other activities? Like here, record that may be consulted but not edited by other staff while information is being entered. We should also have a description of the system state. That means when the scenario finishes. You see here, we have a description. the system state on completion. User is logged on. The patient record, including medical history, is entered in the database. A record is added to the system log showing the start and end time of the session and the nurse involved. Yeah, you see here, we describe precisely when a new patient attends our clinic. A new record is created by a medical receptionist and personal information is added to it. A nurse then interviews the patient and collects his medical history. In this way, the patient can have an initial consultation with a doctor who makes a diagnosis and, if appropriate, will be recommended a course of treatment. So we see that this scenario shows what happens when medical history is collected. This is the technique of scenario. Now we'll see another one, which is the use case. Use cases are a requirements discovery technique, and they are a scenario-based technique in the UML which identify the actors in an interaction and which describe the interaction itself. Here, this technique has become a fundamental feature of the Unified Modeling Language UML. In the simplest form, we have a user case identifies, as we said here, the actors involved in an interaction and names the type of interaction. We can also supplement this by additional information describing the interaction with the system. And the additional information may be some textual descriptions or graphical models like UML sequence or state charts. We'll see UML sequence. I think we will see it perhaps next week. Okay, this is the description of use cases. Also, a set of use cases should describe all possible interactions with the system. As we have said before, sequence diagrams may be used to add in detail to use cases by showing the sequence of event processing in a system. Here we have an example. This figure shows some of the use cases for the patient information system. We see we have medical reception and receptionist, nurse, managers, doctors. These are different people may involved in the system. Then we have some interactions between them, and the interaction, for example, the interactions between medical receptionist and manager is view personal information. That means receptionists can see the personal information. Managers can see it too. And managers and doctors will generate report together. Nurse will, as we have seen before, view, record, edit, record. Doctors can also do these things, and doctors can also set up consultation and generate report. Here, as we have seen, use cases identify the individual interactions between the system and its users or other systems. Each use case normally should be documented with a textual description. And these can then be linked to other models in the UML that will develop the scenario in more detail. Here, for this figure, we may also have a brief description of the setup consultation. use case. Yeah. We may say that setup consultation allows two or more doctors working in different offices to view the same record at the same time. One doctor initiates the consultation by choosing the people involved from from a menu of doctors who are online. Then the patient record is then displayed on their screens, but only the initiating doctor can edit the record. In addition, we normally we create a text chat window to help coordinating doctors to coordinate actions. We may assume that a phone conference or for voice communication will be separately set up. You see here for this, just for this activity, we should provide some detailed information. So when we use this method, use cases, a diagram like this is important and it's helpful, useful for understanding the requirements. But we need also some documentation to clearly show what we want. Now, another technique is the ethnography. The ethnography. Here, we say that ethnography is an observational technique that can be used to understand operational processes and can help derive support requirements for these processes. We say that a social scientist spends a considerable time observing and analyzing how people actually work. As an analyst immerses himself or herself in the working environment where the system will be used. Yeah. With the ethnography, we will observe the day-to-day work and we will note and we will make notes of the actual tasks in which participants are involved. With ethnography, people do not have to explain or articulate their work. Social and organizational factors of importance may be observed. As we say with ethnography, it will help us to discover implicit system requirements that reflect the actual ways that people work rather than the formal processes defined by the organization. And we say that ethnography studies have shown that work is usually richer and more complex than suggested by simple system models. Normally the actual work practices are much far richer, more complex, and more dynamic than the simple models assumed by office automation systems. This technique, ethnography, it is particularly effective to discover two types of requirements. The first one is the requirements that are derived from the way that people actually work rather than the way in which process definitions say they ought to work. Okay, here we may take an example. For air traffic controller, normally we have a conflict alert system. That means, yeah, with the system conflict alert system, we will detect aircraft with intersecting flight paths. But for air traffic controllers, they may switch off the system, even though normal control procedures specify that it should be used. The system should always be turned on. But the controllers may deliberately put the aircraft on conflicting paths for a short time to help manage the airspace. And their control strategy is designed to ensure that these aircrafts are moved apart before problems occur, and they find that the conflict alert alarm will distract them from their work. So you see here, in this situation, it's not just the way which process definition suggests we should do like this. It is rather people actually work. The way that people actually work. We can we can only observe these kind of things by ethnography. It's really difficult to discover or find out these situations with, for example, interviews or scenarios, etc. Another type of requirements with this method technique may be useful is requirements that are derived from cooperation and awareness of other people's activities. Awareness of what other people are doing leads to changes in the way in which we do things. Yeah. Here we may also take the example of air traffic controller. Yeah. The controllers may use awareness of other controllers' work to predict the number of aircrafts that will be entering their control sector. Then they will modify their control strategies depending on that predicted workload. And in this way, automated aircraft traffic controller system, we need to develop it to allow controllers in a sector to have some visibility of the work in certain sectors. As here, in this situation, the controllers need to be aware of other people's activities. And this situation is also spatial. Only with some techniques like ethnography that we can observe these kind of requirements. So we say that ethnography is effective for understanding existing processes, but cannot identify new features that should be added to a system. Yeah, we have seen that developed in a project studying the air traffic control process, and ethnography can be combined with the prototyping. Here, the ethnography informs the development of the prototype so that fewer prototype refinement cycles are required. Also, the prototyping focuses the ethnography by identifying problems and questions that can then be discussed with the ethnographer. Later, they should look for the answers to these questions during the next phase of the system study. Here, this figure shows that ethnography can be combined with prototyping. with ethnographic studies, we can reveal critical process details that are often missed omissioned by other requirements elicitation techniques. However, because of its focus on the end users, this approach is not always appropriate for discovering organizational or domain requirements. As we have said before, ethnographics cannot always identify new features that should be added to a system. Therefore, this technique, ethnography, is not a complete approach to elicitation on its own, and it should be used to complete other approaches, such as use case analysis we have seen before. Yeah, we say the prototype. When we combine ethnography with prototyping, prototype development results in our unanswered questions, which focus the ethnographic analysis. And we have seen that with ethnography, we may have some problems, like it studies existing practices which may have some historical phases which is no longer relevant. Yeah, here is for the ethnography. I think for the validation of requirements, we'll talk about it in the next class. That means next week. Yeah. So for today, we have talked about the requirements engineering processes. We have seen the spiral view of the requirements engineering process. We have also seen the requirements elicitation and analysis. Yeah, we have talked about the different activities of a process model of the elicitation and analysis process. We have talked about the reasons why elicitation and understanding requirements from system stakeholders is a difficult process. We have also talked about the requirements discovery and different techniques of the requirements discovery. We have talked about the interviewing, the scenario, the use case, and the ethnography. Okay, are you still there?
Yes, Laoshi.
Okay, thank you, Kaya. Thank you, yeah, Hosa, Amin, Saddam, Sajid. We have still 5 minutes, and perhaps I will ask you a more question. Thank you, Roy. The activities included in a process model of the elicitation and analysis process. Elicitation. Do you remember the four? Okay, the activities included in a process model of the elicitation and analysis process.
I remember Laoshi.
Yeah, please, Kaya. It's in our class.
It's requirements discovery, requirements
Yeah. Mm.
requirements classification and organization, prioritization and negotiation, and requirement specification.
Perfect. Thank you very much, Kaya. Yeah, it's just this figure has shown exactly the. Thank you, Kaya. You are yeah, totally right. Here, yeah. No, not this one. Oh, we have the figure. Where had I put it? It's before. we had a figure to show a cycle to show the, yeah, it's this one. Discovery, classification, organization, and yeah, discovery, classification, and organization, prioritization, and negotiation, specification. No, yeah, this here, this figure, yeah. And we see it's a cycle. We will return back here if we didn't finish the requirements documentation. Oh, thank you very much. Yeah. Have a good time and see you next week.